خطر. الرجاء الإخلاء فوراً.
غاز.
Okay, listen up. This isn't just another safety briefing. This is the operational algorithm for survival when you're dealing with hydrogen sulfide. With this gas, you don't get second chances. Knowing this protocol isn't just important, it's the only thing that's going to keep you alive. Let's get right into it. First things first, I want you to burn this number into your brain. 100 parts per million. That is the concentration where H2S becomes immediately dangerous to life or health, IDLH. At this level, the air you're breathing poses an immediate threat of death, period. So here's how we're going to break this down. 5 critical sections. We'll start with the threat profile, so you know what you're up against. Then we'll talk about the sensory trap and why your own nose will get you killed. After that, your lifeline systems, the gear that actually works. Then we'll drill the evacuation algorithm. And we'll finish with the rescuer's imperative, which is all about how not to become the second victim. All right, Section 1, the threat profile. You can't fight an enemy you don't understand. And make no mistake, when it comes to H2S, you're fighting an enemy you can't even see. So what is this stuff? Hydrogen sulfide, H2S. It's a colorless gas. You might hear some of the old hands call it sour gas. Doesn't matter what you call it. What matters is that it's a leading cause of death on the job in our industry, and it demands our full respect. Now, you need to understand these properties because each one is trying to kill you in a different way. First, it's heavier than air. That means it sinks, it fills up trenches, pits, any low-lying space, just waiting for you. Second, it's highly flammable. At just 4.3% concentration in the air, you've got an explosive atmosphere. Third, it's corrosive. It will eat away at metal, at equipment, even at the rubber seals on your gear. And last, and this one is critical, it dissolves in liquids. You can have a pit of sludge that seems perfectly safe, but the second you agitate it, you can get a massive, deadly release of gas with zero warning. Okay, let's move on to our next section. And this one is absolutely vital you get this in your head. It's called the sensory trap. This is all about why your own body is a terrible gas detector. If you remember nothing else from this briefing, remember this. This is the first and most important law of survival around H2S. Say it with me. Trust the monitor, not your nose. Let me show you exactly why. Here it is. This is the trap. The science is called olfactory fatigue. At a concentration of just 100 to 150 parts per million, right around that deadly IDLL level we talked about, the gas literally paralyzes the nerve that controls your sense of smell. It just switches it off, instantly. And this right here is the fatal mistake people make. The myth is, hey, I don't smell rotten eggs anymore. Must be safe, the gas is gone. But the reality, it's the complete opposite. The fact that you can't smell it anymore is a terrifying sign that the concentration has just spiked to a deadly level, and your body's only built-in alarm system has just been shut down. And believe me, it gets worse. You get to higher concentrations, around 500 ppm, and you're in knockdown effect territory. One single breath, that's all it takes. You're immediately unconscious, and your breathing just stops. There's no time to scream, no time to react. One breath, and you're down. So if you can't trust your nose, if you can't trust your own senses, what can you trust? Well, that brings us to Section 3, your lifeline systems. This is the equipment that is your only true defense out here. Let's start with your personal monitor. Now, where you wear this thing is non-negotiable. It has to be in what we call the breathing zone. That's the 10-inch bubble right around your nose and mouth. Why? Because the gas is heavier than air. A monitor clipped to your belt could be reading 0, while the air you're actually pulling into your lungs is at a lethal concentration. Clipping it to your collar isn't a suggestion, it's a survival tactic. All right, breathing air before you even think about entering a potentially hazardous area, you have to ask yourself one question. Is the equipment you're carrying meant for work and rescue, or is it just for escape? Knowing the answer could save your life. And here's the difference. On the left, you've got your SCBA, self-contained breathing apparatus. That's the big back-mounted unit. It's designed for working in the hot zone, and it's what you need to perform a rescue. On the right, you have an EBA, emergency escape breathing apparatus. It's a small hood, gives you maybe 5, 10, 15 minutes of air. Its purpose is right there in the name, escape only. You never, ever, ever go into a dangerous area or try to rescue someone with an EBA. That is a fatal mistake. Okay, so the worst happens. The alarm on your monitor starts screaming. What do? This is not something you figure out on the spot. You need a pre-programmed automatic response. This is Section 4, the evacuation algorithm. Your monitor is set up to alarm based on these numbers. Now, TWA and STL, those are for long-term exposure. For evacuation, we're focused on that bottom one, IDLH, 100 parts per million. The second your monitor hits that level and goes off, the algorithm kicks in, instantly. This has to be pure muscle memory. 1. Stop work. I don't care what you're doing, you drop it. Your job is not to find the leak. 2. Mask up. Get that respirator on your face immediately. 3. Wind check. Your eyes go straight to the windsock. You have to know which way the wind is blowing. 4. Move crosswind. You move at a 90-degree angle to the wind. This gets you out of that gas cloud the fastest. And finally, 5. Move upwind. Once you are out of the immediate danger zone, you move upwind to your designated muster point. No thinking, no debating, just do it. And that brings us to our final section. This covers what is, without a doubt, the most dangerous situation you can find yourself in. A man down and a potential rescue. This is the rescuer's imperative. Just look at this number. Over half, more than 50% of the people who die from gas exposure aren't the first person who went down. They're the would-be rescuers, the people who rushed in with good intentions but no plan. So here is the absolute rule. There is no gray area here. You do not attempt a rescue unless you meet all 3 of these conditions. Number 1, you are trained in rescue procedures. Number 2, you are equipped with a proper SCBA, not an escape mask. And number 3, you have backup. If you are missing even one of these, you don't go in, you call for the rescue team. Going in unprepared isn't brave, it's how you become the second body. Okay, let's hammer these points home one last time. These are your critical takeaways. Your monitor is your only reliable sense. Trust it. Know your breathing apparatus. Is it for work or is it for escape? Your first reaction to an alarm is to evacuate, not to investigate. The algorithm is your lifeline, crosswind, then upwind. And finally, an untrained rescuer is not a hero. They are guaranteed casualty. So there you have it. That's the operational algorithm. You have the knowledge now. But the real question is this. When that alarm finally goes off, when the adrenaline is pumping, what's going to take over? Your gut instinct or your training? Your life and the lives of everyone on your crew will depend on your answer. Stay safe out there.
معانا أهم وأحدث المشاريع الإنشائية. وما تنسوش تعملوا لايك وتشتركوا في القناة عشان يوصلكم كل جديد.